Okay, the next thing we want to talk about is integration by substitution. So we'll kind of talk about this more in future lectures as well, but the idea behind integration by substitution is to sort of undo the chain rule. So it's in essence a way of reversing the chain rule for taking derivatives. Okay, so example 2, we want to find the antiderivative, which basically means to find the integral. Okay, so when I'm doing a u-substitution, what I'm looking for is a function inside of a function. So I'm going to write that down. The first thing whoops, maybe I should probably write with the pen. The first thing I'm looking for is a function inside of another. That's the first thing I'm after. Okay, the second thing that I'm looking for is the derivative of my choice somewhere in the problem. Is the derivative somewhere in the problem? If it's not a good choice of u, and I need to try something else. If it is in the problem, I've chosen the correct u, and I can proceed with the u-substitution. Okay, so if we look at example 2a here, we have the integral of 2x times x squared plus 1 squared dx. And so the reason I know that this is a u-substitution problem is because I see a function inside of another function. Okay, so there is the function that is inside of another function. It's the x squared plus 1 inside of a squared. So I'm going to choose u to be equal to the thing that is inside the square. That would be the x squared plus 1. I'm going to then figure out what is du. Well, the derivative of u is 2x and then dx. Here's what I see as far as the problem goes. I see that I have 2x here and dx there. And so that's how I know I have made a good choice for u. So now what I'm going to do is I'm going to substitute so that I can actually find this antiderivative. So this is going to be the integral. The stuff in yellow here is going to get replaced by u, because notice that u is equal to the x squared plus 1. So anywhere I see x squared plus 1, I'm going to put a u, and then it's u squared. Then the stuff in the blue, 2x dx, is going to get replaced by du. So I'm just going to put du down here at the end. Well, now I have the integral of u squared du. I know how to find that antiderivative. It's just using the power rule. So that's going to be 1/3 u cubed plus c. The last thing I want to do is I want to plug back in what u actually is in terms of x. And so my final answer is going to be 1/3 x squared plus 1 cubed plus c. Okay, and that right there is going to be the final answer. Again, as always, if you want to check your answer, just take the derivative and make sure that you end up with what you started. Okay, I'm going to erase these notes that I made over here, so hopefully you're able to copy those down. If not, then you can obviously rewind the video. Okay, in part B, example B here, I'm again looking for a function that is inside of another. Sometimes that's going to be in the denominator, sometimes it's going to be under a square root, sometimes it's going to be in parentheses, sometimes it's going to be an exponent. So that last one that I just said, exponent, is obviously the case here. So u is going to equal to 5x. That means that du is equal to 5 dx. Well, I notice that I have 5 and dx in the problem, and so that's how I know I made a good choice for u. So this is going to be the integral of e to the u du. Well, the antiderivative of e to the u, if you go back to your other page, is just e to the u plus c. And so now if I resubstitute back in what u is, our final answer is going to be e to the 5x plus c. Okay, and again, you can just take the derivative of that. If you're not convinced that that's the answer, make sure that you end up with 5e to the 5x as your answer whenever you take the derivative. Now, this paragraph towards the bottom of page 5 of the notes is basically just talking about the fact that in example 2, the constant that we needed was in the problem already. That is not always going to happen, and in fact, it's usually not going to happen. And so in the next page of the notes, on page 6, we're going to show you how to work problems where that constant may or may not be there. Okay, so example 3, find the antiderivative and then integrate, and really that's talking about the same thing. Okay, so example A, this is very similar to the first example of example 2, except this time we're missing the 2 that's in the front. So we'll talk about how to deal with that. And I just noticed that there's a typo on these notes, so I'm going to put in that squared there so that that's on there, and then I'll correct that on your notes on my web page. Okay, so again, I'm looking for a function inside of another function, and so in this case, that would again be the x squared plus 1, since that is inside of a square. And then I'm going to take the derivative of that. So the du is going to be 2x dx. Okay, well, what I notice is that I have the x dx part, so the x dx part is here and here, but what I'm missing is a 2. And so what I'm going to do with this equation right here is I'm going to solve for what I have. I have x dx, and so I'm going to solve for it and make it say 1/2 du is equal to x dx. And so now for that x dx, we're going to substitute in 1/2 du. So this is going to say 1/2 the integral. Du is going to be down here at the end, and then this part in yellow, okay, just like it was on example 2, that yellow is going to get replaced by our u. So this is going to say u squared. Okay, so now we take our antiderivative. So this is going to be 1/2. The antiderivative of u squared is 1/3 u cubed plus c. If I want to simplify that, that's going to be 1/6 u cubed plus c. And now I want to plug back in what u was. If you look back up there, u is equal to x squared plus 1. So this is going to be 1/6 times x squared plus 1 cubed plus c. And again, I'm going to reiterate this a couple of times. You can take the derivative in order to check whether or not you did it correctly. Okay, example B, I'm looking for a function inside of another function, and I'm hoping that the function that I choose has its derivative somewhere in the problem up to a constant. Okay, well, hopefully if you look at this, you're able to recognize that our u is going to be x cubed minus 2, since that's the function that is inside of a square root. That means that du is going to be 3x squared dx, but I don't have 3x squared dx in the problem. All I have in the problem is the x squared dx. I have it here and there. So in order to compensate for that, we need to solve for x squared dx, which just means we need to divide both sides by 3. So that's going to say 1/3 du is going to equal to x squared dx. Okay, so now for everything that I see in blue there in the original problem, we're going to replace that with 1/3 du. Okay, so this is going to equal to 1/3. Integral sign just stays an integral sign, and then du, I'm going to draw a little line here so that things kind of stay separate. And then for the yellow piece, let me get the yellow going here. For this piece under here, that's going to get replaced with u. But that is underneath a square root, and so I'm going to rewrite that as u to the 1/2 power. Okay, once I get that done, now I need to take the antiderivative of u to the 1/2. So that's going to be 1/3 multiplied by 2/3 u to the 3/2 plus c. And then the final thing is to get the constant cleaned up and then resubstitute back in what u was equal to. So that's going to say 2/9 multiplied by x cubed minus 2 to the 3/2 plus c. And that will be our final answer for example B there. Okay, example C, we have the integral of x over x squared plus 9. So again, we're looking for a function inside of another function whose derivative is somewhere in the problem up to a constant. Okay, so if you take a second to think about this, hopefully you recognize that x squared plus 9 should be our choice for u. The reason for that is because du is 2x dx, and what I notice is that I have the variable part of du in the problem, and I'm just missing the 2. Okay, so I'm going to go ahead and solve this equation for x dx. That's going to say 1/2 du is equal to x dx. And now all of the blue stuff in the problem is going to be taken out and replaced with 1/2 du. So this is going to be 1/2 the integral of du. Okay, then the part that's underneath the square root here, that's going to get replaced by u. So what we're going to end up having is 1 over the square root of u. Now I can't take the antiderivative of 1 over the square root of u. I've got to rewrite that in a format that makes it easy to take the antiderivative. So I'm going to rewrite it as u. Since it's in the denominator, I know it's going to have a negative exponent, and since it's a square root, I know that the exponent is going to be the negative 1/2 power. Okay, so this is going to end up being 1/2. Now I'm going to take the antiderivative of u to the negative half, which is going to be u to the positive 1/2, divided by a half, which is really times 2, plus c. And so what ends up happening is that 1/2 and 2 cancel out, and I get u to the 1/2 plus c. So I'm going to go ahead and rewrite what u was. U was x squared plus 9 to the 1/2 plus c, or another way I could write that is the square root of x squared plus 9 plus c. Okay, example D. We have the integral of x plus 1 over x squared plus 2x. Well, again, I mentioned earlier that your choice for u is typically going to be in parentheses, in an exponent, under a square root, and possibly in a denominator. So if you choose the denominator here, that would be x squared plus 2x. That means that du is equal to 2x plus 2 dx. Well, that's got to be somewhere in the problem, but up to a constant. Well, notice that 2x plus 2 can be factored. So I could factor out a 2 from that, and that would leave me with x plus 1 multiplied by dx. That is what I see there in the problem. Okay, so if I get the blue going here, the x plus 1 dx, that's going to get replaced after we come down here and solve our equation for what we have. That's going to be du over 2 is equal to x plus 1 dx. Okay, so this is going to be the integral. The 1/2 is going to go in the front, the du will go at the end, and then I'm going to replace this stuff that's in the yellow. So this stuff, whoops, sorry about that. This stuff in the yellow is going to get replaced by u. Well, the x squared plus 2x is in the denominator, so this really ends up being 1 over u. Okay, I need you to get used to recognizing that 1 over u du, the antiderivative of that is natural log. So this is going to be 1/2 the natural log of the absolute value of u plus c. And just to kind of reiterate why that is, remember that this is u to the negative 1. And if I try to increase the exponent by 1 and divide, I can't do that because I'd be dividing by 0. And that is how you should think about why you need to use the log rule as opposed to the power rule. Okay, so our final answer here is going to be 1/2 the natural log of the absolute value of x squared plus 2x, and then plus our c. Okay, last two examples here, and then we're done. So we have the integral of x cosine of x squared dx. Okay, so u is going to equal to some function that is inside of another function whose derivative is somewhere in the problem, except for maybe a constant. So in this case, our u is going to be x squared, which means that our du is going to be 2x dx. And again, notice that I have x and dx in the problem. I'm just missing the 2. So I'm going to go ahead and divide that to the other side so that x dx is solved for. And so what I'm going to end up having is 1/2 the integral of du. And then this rest of this stuff here is going to get replaced by cosine of u. Okay, remember that this x squared is now equal to our u, and so that's why I put in u instead of x squared. Okay, well, the antiderivative rule for cosine of u is sine of u plus c, and if I replace what u was, I'm going to be done. So 1/2 sine of x squared plus c. Okay, so again, take the derivative of your answer, make sure you get the same thing. Okay, last problem, e to the 4x. This is very similar to example 2b. So again, u is going to equal to the exponent, which is 4x. That means that du is equal to 4 dx, but because we don't have a 4 in the problem, we're going to need to divide by 4 on both sides, so that dx gets replaced with 1/4 du. So 1/4 the integral of du, and then that's just e to the u left over, and the antiderivative of e to the u is just e to the u. So this is 1/4 e to the 4x plus c. Okay, that was a lot of examples, so if there's anything that you don't understand about something, please contact me and get in touch with me and ask me questions about what you do not understand. Good luck to you guys, and hope the assignment goes well.